Hi friends, I'm Grishma and you are watching my channel G Tutorial. In today's class, let us learn about K-map and the rest of the logic gates which I have discussed in the previous class. If you like my video, please subscribe to my channel for getting more RRB JE related videos. Now let us get to a portion. First let us see what is meant by K-map. K-map or Karnaugh Map is a systematic method of simplifying Boolean expression. We have already seen how to simplify a Boolean expression, and K-map is another method for simplifying the Boolean expression. It consists of an arrangement of adjacent cells. These are called cells. It's an arrangement of adjacent cells, each representing a particular combination of variables in sum or product form. And in these cells, the variables are arranged either in SOP format or in POS format, or in terms of max terms or min terms. And we can see if there are n number of input variables and m is the number of cells. For example, let n is equal to 2. We are considering a 2 variable K-map. So the number of input variables is 2, that is A and B. So the possible number of cells in a K-map is m is equal to 2 raised to n. N is 2. So 2 square is 4. So the possible number of cells is 4 cells. For representing a 2 variable input, we need a 4 variable K-map. 4 cells should be there in the K-map. This is the 2 variable K-map. The possible input combinations are 0, 0, 0, 1, 1, 0, 1, 1. So we need a 4 cells to represent these 4 input combinations of this A and B variables. And if the distance between any two cells is 1, then the cells are called adjacent cells. See here, the distance between these two cells, 0 to 1, there is a 1 bit change. From here also, 0 to 1, there is a 1 bit change. If you are considering 0, 0 to 0, 1, here also there is 1 bit change. So these are adjacent cells. 0, 0 to 0, 1 to 1, 0. Here 1 change to 0 and 0 change to 1. So there is 2 bit difference. So these two are not adjacent cells. These two are but adjacent cells. You can see this when we are seeing 3 variable or 4 variable K-map. Now let us see about 3 variable K-map. This is a 3 variable K-map. In 3 variable K-map, the number of input bit is 3. So the number of cells is given by m is equal to 2 raised to n, that is 2 raised to 3. So there will be 8 cells. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 cells in a 3 variable K-map. The possible input combinations are 0, 0, 1, 0, 0, 0, 0, 0, 1, like that 1, 1, 1. We have learned that for a K-map, the adjacent cells should be at a distance of 1 unit. So there should be only 1 bit change between adjacent. So 0, 0, 0, 1. But between 0, 1 and 1, 0, there is a 2 bit change. So we are writing 1, 0 over here and 1, 1 over here. So that there is only a 1 bit change between the adjacent cells. 0, 1 to 1, 1, there is only 1 bit change. From 1, 1 to 1, 0 also there is only a 1 bit change. Similarly 0 to 1, 1 bit change. So the we can 0, 0, 0 means our 0. 0, 0, 1 means 1, 2. 0, 0, 1, 0 is decimal 2. 0, 1, 1, 1 is 3. So we are writing this decimal equivalent like this. 0, 0, 0 is 0. 0, 0, 1 is 1. 0, 1, 0 is 2. So 2 comes here. 0, 1, 1 is 3. Similarly 1, 0, 0 is 4. 1, 0, 1 is 5. 1, 1, 0 is 6. So 6 comes here, not here. 1, 1, 1 is 7 and 7 comes here. So the output that appears in each of this instead of M0. We are just considering the SOP format so that each term is min term. So that min term M0 is written in the first cell, that is 0th cell. M1 is written in this cell. M2 is written in this cell, like that. We can understand it clearly while doing problems. Similarly, in the case of two variable K map, on following the truth table, 0, 0 is 0, 0 this position, 0, 1 is this position, 1, 0 is this position, and 1, 1 is this position, 0, 1, 2, 3. Okay, now we can see the 4 variable K map. Next, let us see the 4 variable K map. This is the possible input combinations. If you are considering 4 variable means n is equal to 4. So the number of inputs, number of cells in the K map is m is equal to 2 raised to n, which is 2 raised to 4, which is 16. So there are 16 cells in the K map of a 4 variable K map. The possible combinations are 0, 0, 0, 0 to 1, 1, 1, 1. And we have learned that between adjacent cells of a K map there should be only a one bit change. So 0, 0, 0, 1, 1, 0, 1, 1. Similarly here also 0, 0, 0, 1, 1, 0 and 1, 1. So the binary decimal equivalent of this will be like 0, 0, 0, 0, 0, 0, 0, 0, 1 is 1. 0, 0, 1, 0 is 2, which comes here. 0, 0, 1, 1 is 3. Similarly, 4 appears here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Now let us see some more points about K map. The following points should be kept in mind before solving a Boolean expression using K map. First thing is that the map is considered to lie on a surface with the top and bottom edges as well as the right and left edges touching each other. It seems like these two edges touch each other and these two edges touch each other. That should be the first point that is to be kept in mind. Second is don't care can be treated as either 1 or 0. Don't care is something which occur in cases where output is uncertain. For certain combination of input, the output is not known, whether it is 0 or 1. So, we are taking it as don't care. In SOAP expression, we are taking don't care as 1. And in product of sum expression, we are treating don't care as 0. Next is the mean term or max terms are grouped either as pairs, quads or octets. Pair means a combination of 2 is called pair. Quads means combination of 4 and octet means combination of 8. And in a pair eliminates one variable. Quad eliminates 2 variables and octet eliminates 3 variables. You will understand it clearly while you are solving problems. I will take an example and make you understand. This is a K map and we are asked to solve it. Or we are asked to find the simplified expression of this K map. I'm not going to deal with that now. Let us study from the basics, but to make you understand these points, I'm just saying. First thing is, this is a K map and we are asked to solve it considering that each of the term is mean terms. That is, this represents a sum of product expression, a Boolean expression. So, we have to group, in case of sum of product expression, we have to group all ones. We can also consider don't care as 1 and it is not necessary to group all don't cares. So in this case this is a pair of 2. We always have to pair as larger one. That is, if octet is possible, the first type of grouping that we should choose is octet. That is, if we are possible to cover the whole ones as an octet. It's a pair of 8, then we should do that. Otherwise, quad. Now let us check for a quad. First point is that the right and leftmost edge as well as the top and bottom edge are touching each other. So, we can form a quad instead of 2 pairs. If they are not touching each other, we are not considering that way, we will form only 2 pairs. But we know that these two ends touch each other. we should consider like that. So here there forms a quad. And a quad and a pair is formed. How to write the simplified Boolean expression I will explain to you from the very basics. That is from two variable K map we can start. This is the first question. We are asked to find the minimized expression for each of the K maps. In the first question, each of these questions we are considering a sum of product expression. That is, each of these terms are min terms. So we are considering the output as 1. Expression for those only whose output is 1. So here there is only 2 ones. So the possible group we can form is a pair of 2 ones. So 1 and 1 forms a pair, and how we are writing the minimized expression for that is like this. In this pair we have to move in this way as the group is formed in horizontal direction, and in that only the variable A is not changing, but B varies from 0 to 1 in these two adjacent cells, but the value of A is 0 in these two adjacent cells. So the value of this expression or output of the expression is A. A is 0. So A bar. This is the expression for the first K map. In the next K map, we should always form a pair, a group, not a pair, a group which is the largest. That is, if it is possible to form an octet, you have to take that. If you are possible to take a quad, then you have to choose that. And in the least possible case, you should take a pair. In this case, there is 2 ones and 2 don't case. You are possible to take a pair, 1, but you are available with this don't case. So you have a possibility of taking a quad. So you should take that quad, a group of 4. It should be your choice. And in that case, this simplified minimized expression will be B changes from 0 to 1 and also A changes from 0 to 1. So the answer is just 1. Y is equal to 1. It is the minimized expression for this K map. And in this case, you are not possible to form a quad because here there is a 0. You should pair only ones and don't care in case of sum of product expression or min terms. So it is not possible to take the 0. So you can form a pair like this. But you may think that you can also form a pair with 1 and don't care. But it is not necessary because this one forms with this pair. So it is not necessary to take this one. Because here it is a don't care. We will see about it. It is a these are client implicants. We will see about that later. It is only necessary to consider this pair. So the output is, or minimized expression is, here A is not changing. The value of A is 0. So A bar. Output is A bar. Next one. This is a 3 variable K map. Here it can be easily solved. You can form a quad. And in this case, the value of A changes from 0 to 1, B changes from 0 to 1, but C changes from 1 to 1. That is, there is no change for C. So the output is C. We have studied that in a 2 variable K map, a pair eliminates 1 variable. This eliminates 2 variables, and octet eliminate 3 variables. So in this quad eliminated 2 variables. A and B is eliminated. The output is C. Next is this question. Here you can form a pair. Next is a quad. We have seen that the 2 right and left edges of a K map touch each other. So a quad and a pair. The equation of quad is 0 to 1 variation is there. 0 to 1 variation is there. C is not varying. So it is not C. C is equal to 0. So 0 C bar plus. We are writing a SOP expression. Sum of product expression. So plus. Sum of product. Next term is this pair. In this pair, the value that is not changing is A is not changing, but it is not A bar. Since A is 0. Next is B is also not changing. So B bar, B is 0. But the value of C changes from 0 to 1. So it is not taken. This is the expression for, simplified expression for this K map. Next, let us see what is meant by prime implicant and essential prime implicant. A group of adjacent minterms is called prime implicant. That is, all possible pairs, quads or octet are called as prime implicant. We can understand this prime implicant and implicant clearly by solving this example. And essential prime implicant means those prime implicants which contains at least one minterm which cannot be covered by any other prime implicant. That is called essential prime implicant. We can solve this. This is a 3-variable K map and we are asked to simplify this sum of product expression. So we have to group all ones, and the possible combination is we are not able to form a octet, we cannot form a quad. The only possibility is to form pair. This is a pair, this is a pair, and this is a pair, or this is a pair. The expression for the first pair is A is not changing and also the B is not changing. So the expression for the first pair is both are 0, so A bar B bar. The second pair is this one, which is here A B. Next pair is this one. Here 0 1. 0 1 is B bar C. And this is the another possible pair, which is 1. So A C. These are the 4 possible pairs. And what is meant by prime implicant means these are the prime implicants that is possible. That is the possible combination of pairs or quads or octet is called. Here there is no octet or quad, so we are considering pair. Each of this is called prime implicant. And the one which is which does not form a part in another pair, that is called essential prime implicant. Here this one and this one. That is A bar, B bar, and AB does not take part in any other pair. But this and this are not essential prime implicant. Only this one and this one. 0 0 and 1 0 does not take part in any other pair. So A bar, B bar and AB are the essential prime implicant. It does not take part. Prime implicant, these are prime implicant which contains at least one minterm which cannot be covered by any other prime implicant. This minterm and this minterm does not take part in pairing with the others. So only one possible pair or quad or octet is possible. So if the prime implicant contains such a minterm, then it is called essential prime implicant. Now let us do some more problems. This is the next question. Find the minimal expression for sigma m of 2, 3, 6, 7, 8, 10, 11, 13 and 14, and also implement these using basic gates. So first we have to find the minimal expression or reduced expression for the given sum of product. That is 2, 3, 6, 7. These are the minterms 2. So we have to, the output is 1 for these minterms. So in the K map, this is, we can see that there is a minterm till 14. So we should use a 4 variable K map. This is a 4 variable K map and there are 4 variables A, B and C and D. Now let us represent these minterms whose outputs are 1. So 2, 3, 6, 7, these values are 1. So 2 is 1, 3 is 1, 6 is 1, 7 is 1, 8, 10, 11, 13 and 14 is 1. So these are the possible output of this expression. This is the canonical or the basic expression. Now we have to simplify it using K-map. So we have to form a group of these. First let us consider whether it is able to form an octet. For 8 pair is not possible since one is missing here. Here also one is missing over here. So we cannot form an octet. Next let us try for a quad. Here is a quad. Then this is a quad. This is another quad. So 3 quad is possible. Next let us see whether we are able to form any pairs. So if we are considering this one, then this one and this one will form a pair. But this one does not form a pair, quad or octet. So let us write the expression for each of this. First let us take this one. So the output is, this one does not form any quad, pair or octet. So 1 1 0 1. 1 1 is for A and B. A, B. 0 1 is C, D. C is 0. So C bar D plus. Next is the pair. These two ones forms a pair. So 1 0. 0 0 1 0. So 1 0 is for A and B. B is 0. So B bar. Next is the value that is not changing for this pair is C changes from 0 to 1, but D changes, D does not change. That is D is 0 in both these cases. So D bar. Next, let us consider each of these quads. First quad is this one. So in this quad, here A is not varying but B varies. So value of A is 0, A bar. And here 1 1 and 1 0. C is not changing. Value of C is 1, so C is written as such. But D changes from 1 to 0, so it is not taken. Next is this one. Its value is 1 0. C D. D is 0, so C D bar. Next pair is this. Next quad is this and this. So the value is in here B is not changing. 0 0 to 1 0, B is not changing. So B bar. Value of B is 0. And here from C is not changing but D is changing. So C. Value of C is 1. This is the output of this K-map. And when we are not using any of the grouping technique, 4 variables exists. When we form a pair, we have seen that 1 variable is eliminated. Here C is eliminated. When we form quad, 2 variables are eliminated. B and D are eliminated here. Here A and B are eliminated. Here A and D are eliminated. Only 2 variables will be existing when we form quad. Now what is asked next? We are also asked to implement this using basic gates. We have to implement this expression using basic gate. We can see that next. This is how we are implementing using basic gates. A line represents each of the input variable A, B, C, D, and for representing A bar, B bar, C bar, we are using a NOT gate. NOT gate inverts the input. So the output of this NOT gate is A bar. Here it is B bar, C bar, D bar. Now let us implement this expression using this gate. First expression is A, B, C bar, D. Here we are AND operation of these 4 variables. First variable is A. So from here we are taking A. Next is B. B. Next one is C bar. So we have to take from the output of this NOT gate. C bar. Next one is D. D. So we are adding these 4 and the output is A, B, C bar, D. Next is A, B bar, D. So A, B bar, D. This is A, B bar, D. Next one is A bar, C. So A bar, C. This is A bar C. Next is C D bar. So C D bar. Next one is B bar and C. B bar C. And finally we are taking OR operation of each of these outputs. So this is our output Y. Now you have seen how to solve this SOP expression using K-map and how to implement using the basic gates. This is the next question. Find the simplified pose expression for the given K-map. Here we are asked to find the product of some expression. That is, we are grouping zeros over here and we should take don't care as 0. So the possible choices are, first we have to we should try to get an octet. If it is not possible, go for a quad. Here we are possible to take an octet. This is an octet by grouping zeros. So the simplified expression for that is, here x is changing 0 to 1, and in these 4 cells all the variables are changing. So only the value of y is not changing. Y is equal to 0. Let us take some other variable to represent the output function. Let it be f. So y is not changing. So the value of y is 0. And in case of pose expression, when the value is 0, we are taking it as that variable itself. And in case when y is 1, we are taking it as y bar. So here y is 0. For this octet, the value of output is y and the value of y is 0, so we are taking it as y itself. Next is we have to express as product of sum. So product and using and. Next term is let us form any other octet. If you are taking this, 1 occurs there. So the next possible choice is only a quad. This quad. And there is no other possible choices. No pairs or octet is possible. So this is the next quad. Its expression is x is not changing. So value of x is 0. So x is kept as such. Next is from here to here, w is not changing and the value of w is 0. So plus w. This is the second term and this is the first term, and product of sum. This is sum. This represents a quad, this represents an octet. When using an octet, we can eliminate 3 variables, x, w and z is eliminated, and here x, y and z is eliminated. So this is the output of the given K-map. Now we have studied about K-map and how to simplify a given K-map. If you are having any doubt, you can comment below. Thank you.